Okay, starting on the top of page 3 of your notes, this is the section where we learn about significant figures, and this tells us how many decimal places that we're going to round to at any point in time. So from here on out, it's expected that you understand on your own how many decimal places are appropriate to round to, or if you don't need decimal places, whatever. So first of all, fractions are going to be exact, meaning that there is no rounding required for fractions, and they should be used whenever possible. So if you are taking half of something, you can put 1/2, and that's going to be considered exact. However, most of the answers that we get in chemistry class on the calculator will need some kind of rounding. The rules for significant figures tell us how many decimals we will need to use in our final answer based on the exactness of the numbers that we use to solve the problem. So there are several rules for deciding if a number is going to be significant, and you need to memorize these rules. So we'll go through them carefully, and then we'll make like a little cheat sheet for ourselves. The first rule, pretty straightforward and simple. Anything that is not a 0, so all non-zero digits, are always going to be significant. So if you have a 1 or a 2, 3, 4, 5, 6, 7, 8, or 9, any of those digits, anywhere they appear in a number, are always going to be significant. If you have a 0 between non-zero digits, it will be considered significant. These are what I call trapped zeros. Meaning if you have a 0 trapped between two non-zero digits, that 0 becomes significant. So for example, if you have 5, 0, 6, that 5 is significant because it's a non-zero digit. The 6 is significant because it's a non-zero digit. And then the 0 becomes significant because it's trapped. There is also not a limit to the number of zeros that can be trapped and be counted significant. So it could also be like you have 1, 0, 0, 0, 7. Because the 1 is significant and the 7 is significant, all of the zeros that are trapped between them are also significant. And this also applies to when there's a decimal in the number. So if you have something like 1.0008, all of those zeros are also significant. So I have the 1 and the 8. Even if there's a decimal thrown in there, doesn't matter at what point it is, those zeros are still trapped, therefore they're going to be significant. The other type of 0 that we have is zeros in front of non-zero digits. I call these leading zeros. So if you have zeros in front of a non-zero digit, they are never going to be significant. So for example, if you say I have, 7 pencils, you're not going to write 07. That 7 right there is not, the 0 is not significant, but the 7 is. Or if you have 006, again, each of those zeros are not significant, so we drop them. But the 6 is significant. I don't know how well the color is translating, but I'm using red and green to show. Let me see if I can turn a light on. No. Okay. Oh, this one. Did that help at all? I feel like that made it worse, actually. Okay. Then, the other part that matters in this is that a leading 0, even when there's a decimal, is still going to be insignificant. So any of those are not significant because they are in front of the non-zero digits. So none of those are significant, but the 9 is. If I have something like 0.0804, if we're looking at this, I automatically know that any of my non-zero digits are significant. So my 8 is, and so is my 4. What about this first 0? Would that be significant? No, because it's a leading 0, so that's not significant. What about this one? Also a leading 0, so not significant. What about this one? Yes, because it's trapped. So it will never be like significant, not significant, significant. If you have significant on one side and significant on the other side, everything in the middle is also automatically. So far, so good? Okay. Thanks for the thumbs up. I appreciate that. All right, and then the last type of 0 that we're going to talk about is a trailing 0. So a trailing 0 is a 0 that is behind any integers. And this rule is the one that confuses students the most because it's a sometimes thing. Trailing zeros are significant, and I worded it this way on purpose. If there is a decimal point in that number, that does not say that they're only significant if they are behind the decimal. It says that they are only significant if the number has a decimal, period. So what I mean by that is if I have the number 30, there is no decimal in that number, therefore that 0 is not significant. But the 3 is significant. If I have the number 30 with a decimal at the end, and I know this looks super awkward because it's not traditionally how we see numbers. However, when it comes to significant figures, this is an acceptable way to write a number. If I have 30 with a decimal point at the end, my 3 is still significant because it's a non-zero digit. And because there is a decimal point in the number, that trailing 0 that comes at the end of the number is also significant. So both of these are significant. If I have 30.0, is my 3 significant? Yes. Is the 0 right after the 3 significant? What about the 3 at the end? Yes. You can still have leading zeros in this case. If you have like 0.000650. So if we're looking at this one, my advice is always to start with the non-zero digits. That should help you out every time because those are always significant. So I know I have 6 and 5 will be significant. What about these guys in the front? Is this one? What rule would this fall under? So if you think about this first 0, is this a trapped 0, is it a leading 0, or is it a trailing 0? Leading 0. So is my leading 0 going to be significant? No. Leading zeros are never significant. What about the next one? What rule would that one follow under? Trapped, leading, or trailing? Maybe I didn't do a good job explaining trapped. So the trapped zeros are going to be only zeros that are between non-zero digits. Is this between a non-zero digit? No. So even though it's after the decimal, it's still a leading 0, which means that that would be not significant. And that also means that these would not be significant. My 6 and my 5 I've already established are significant. And then I have these trailing zeros at the end. So if you are in the trailing 0 asking the question, is there a decimal point in that number? Yes or no? This number? Yes. So if there's a decimal point in that number, then the trailing zeros are significant. So we have the 0 and the 0. So part of the reason for this is that, or actually really the only reason for this, the main reason is so that scientists can communicate to other scientists how exact their values are, how exact their numbers actually are. So scientists will usually only estimate the last digit in a number. So if they put trailing 0, sorry. So if they put it trailing 0, a 0 behind. I'm sorry. 0 behind. It means the same thing, but grammatically. 0 behind the decimal. It's how a scientist will tell another scientist that it is an exact measurement. So it's the difference between saying I have about $20 in my bank account versus I have $20.00 in my bank account. The zeros behind the decimal tell you how exact you're being with the information that you're providing. So this will come into play when we talk about our equipment. If I have a piece of equipment in this class, such as a graduated cylinder or a beaker or a scale, and it doesn't measure very precisely or very exact, then the number of decimals that you use or don't use tells me how precise our equipment actually is. So I'm going to pause the video for just a second to give us time to work through these examples, and then we'll pick back up and talk about the rules for significant figures in math calculations. Picking back up on our examples, I'm going to go through and then just highlight the significant digits in each number. So first one should be pretty easy because there are no zeros, and so if it's a non-zero digit, it's always significant every time. So the 1, 2, 3, and 4 are all significant. So we have a total of how many significant figures in this number? 4. In the next one, the 1 is significant and the 2 is significant. So I highlight those first. So I have at least 2 sig figs. And then there are 2 zeros that I would describe as trapped in between those non-zero digits. So they are both significant because trapped zeros are significant every time. So 1, 2. So that gives me a total of how many? 4 significant figures. I'm going to real quick do a little like cheat sheet out to the side. So if you are struggling with these, I think of it as like sometimes, always, never. If you are a leading zero, you are never significant. If you are a trailing zero, you are significant if you have a decimal. So significant when decimal, even if it's not after the decimal. And then if you are a trapped zero, you are always significant. So if you keep those in mind, that will help you. And then any notes you give yourself for your quiz, we'll talk more about that later, like making a cheat sheet. I would definitely put that on there, and whatever words make sense to you. All right, next part is I have a 1 and a 2 and a 3, so I'm automatically going to say each of those are significant. That was weird, it's like delayed. So the 1 and the 2 and the 3 are significant in that number. What about this 0 in front? What type of 0 do we call that? Leading 0, which is never significant. And then what about the 0 at the end? What type of 0 is that? That is a trailing 0, and trailing zeros are significant when you have a decimal. So since there is a decimal in that number, that trailing 0 becomes significant. So how many sig figs in this whole number? 4. Perfect. Then we have 5.69 meters cubed. Didn't notice the units on here. All right, then this is significant, that is significant, and that is. So that's a total of 3. The next one, I have 0.001. My 1 is definitely significant. What about this 0 that comes before the decimal? It's a leading 0, so what would I call? I would say not significant. What about this 0? also a leading zero. It's not trapped between two non-zero digits, and it's definitely not at the end of the number. And then that means this zero is also a leading zero. So that is how many sig figs? Perfect. Scientific notation, if you remember from the front page of our notes when we talked about scientific notation, we used this term significant figures, but we didn't really know what it meant yet. So if you're looking at this, there's only one digit before the decimal, and then remaining significant figures come back here. So in scientific notation, this whole thing is going to be significant, and this is just a placeholder to tell you how many zeros you need to use, or how many times to move the decimal, sorry. So in scientific notation, this part is always going to be significant, this part is never. So you're just going to count all of the digits that are in that part. There will always be a decimal in it, since that's the format that we have. So if I have 3 and then 2 trailing zeros behind a decimal, that gives me 3 significant figures in this one. In this one, number 7, my 5 is significant, my 6 is significant. There's a 0 trapped between my 5 and my 6, so that one is significant. And then I have 2 more zeros at the end. Since they're at the end, I would call those trailing zeros. And trailing zeros are only significant when there is a decimal in the number. There is no decimal in that number. So are those zeros at the end significant? No. So no and no, which would mean that this number has 3 significant figures. And then for number 8, I have a whole lot of leading zeros. They're all going to be insignificant because leading zeros are never significant. And then all of my non-zero digits, 1, 2, 3, 4, are significant. So that means that has 4. So hopefully that helps clear things up for you. I'm going to stop the video here.